Most of the milling time on this model will be dedicated to carving this terrain surface accurately. This will be undertaken using a 3-axis toolpath known as parallel finishing, which was discussed earlier. However, before this is to occur, there exists a fair amount of excess material that needs to be removed before we can apply this toolpath. This process is called roughing and involves using a thicker router bit to remove this excess material very quickly. Both the roughing and finishing toolpaths require 2 pieces of geometry to succeed: a surface, polysurface or mesh to generate the toolpathing across, and a closed planar curve showing the extents of this region to mill. We already have the surface, which is our terrain, and we just need to generate our containment region. We can do this by selecting our terrain and going dupe border, which is a command that will duplicate all the borders of the polysurface, mesh or surface in question. I'm now going to invert the selection and hide all other geometries so we can see this in a bit more detail. So from here we've got a series of 3D curves. We need these to be planar, so we're going to use set point, which allows us to control the specific coordinates of the x, y, z values for each control point on all these curves. So we just need to have Z selected and either select the top of our stock or type 100, which is the location where our containment region needs to be. So you can see now you've got all the paths and roads coming up as well, which we don't really want. An easy way to delete this is to just explode it out and then select all these curves in question, delete, and then join our curve, and then go close curve to fill in the small gap at the top. So now we can go show and start putting everything on the right layers. So this containment region needs to be placed on the layer in our 3-axis toolpath parent layer called containment region. I'll just make that a little bit bigger so you can read it. So containment region, so the closed planar containment region goes on there and should turn white as a result. Now I'm just going to hide our stock layer so I can put everything else on our 3-axis part layer as well. So that's fulfilled all the requirements we need for the 3-axis surface milling toolpaths we're going to use. The next video will talk about the few 2-axis toolpaths that we're going to be using to create mainly our trees. In the next video, we'll be aiming our learning towards setting up our toolpath geometry for some 2-axis operations.